continent of Africa is many times the size of Western Europe. Yet in Africa there are few paved roads and there is little public transport. It is in Africa, not in Europe, that the car and the light commercial vehicle are essentials rather than luxuries. There are no viable alternatives. Despite this, in over 200 years of motorized transport and 100 years of the motor car, few vehicle makes and models have in any way been suitable for use in Africa. These are experimental cars for Africa. They've been developed after a detailed study of the compromises endemic to the history of transport. The three prototypes, the wagon, the pickup and the six-wheeler, are on a critical 30,000-kilometre proving journey from the Arctic Circle in northern Sweden to the Equator in East Africa.
You've got that, Bob. Try and fix the fog lamps.
For the crew, travelling with no backup vehicles, it promises to be a long, nervous and lonely journey.
Come in, Liza.
It was in France, not in Germany, America, Italy or Britain, that I had found the engineering tradition appropriate to the requirements for the Africars. So we've stopped in Paris to look at the origins of the motor industry, the modern motor car, and the design of multi-purpose vehicles. This strange-looking vehicle is, as the plaque here says, quite simply the first automobile in the world. Built in 1771 by Nicolas Cuneau in Paris, designed as a military tractor. It has a boiler at the front, two cylinders driving through a ratchet system, so the motion would have been like that. A very, very heavy load on the front wheel, which is the driving wheel. Up on top here, it's quite a good driving position, quite comfortable, very good visibility. There is a brake, which is rather amazing. It's a sprag that digs into the treads on the front wheel. Behind is a huge load-carrying space for carrying a gun or ammunition. In the same Paris museum is a later, garish example of the French marque that had, by 1893, become the world's first classic car. This Panhard of 1898 is the vehicle which established the form of the modern motor car, or at least the form of the motor car for perhaps its first 50 years. The engine is in the front, there is a 4-speed gearbox, the rear axle is driven, in this case by chain, but the actual layout is the same layout that you would find, say, with a Ford Cortina, or even the Ford Sierra of 1984. By 1900, France had the world's largest car industry and a component supply network that provided engines and other parts for many vehicles thought to be the product of other countries. Although France continued to be the world's main exporter of cars till 1912, America, with its large home market, took over as the largest vehicle manufacturing country in 1906. A year later, the Model T Ford was introduced. In a way, the world's first, and for the moment possibly the world's last, real multi-purpose vehicle. Over 15 million Model Ts were sold between 1907 and 1927. They had a range of bodywork from buggies and sedans to vans, pickups, flatbeds, and even tractors. By 1920, half of all the motor vehicles in the world were Model T Fords.
Good morning.
Yeah, will be. After that, Joseph.
The Model T Ford was built as much for the American farmer as for the city dweller. It had about a foot clearance under the axles. That's about 30% more than the average modern four-wheel drive. The Model T was cheap, had a wide track, a sensible wheelbase, not too long, not too short, and it was light. With a 3-litre engine and in this body form, this vehicle weighs about 650 kilograms, and that's half the weight of the average modern all-terrain vehicle. The suspension is not independent, but there is a transverse spring which allows the axle to articulate, to follow the contours of the ground, as well as absorbing the vertical bumps. Altogether, an elegant, practical example of vehicle design. Shall we go? In 1927, as American roads improved, Henry Ford abandoned the multi-purpose concept, and the 1920s saw the end of America as a source of innovative vehicle technology. The initiative returned to France. This is a 1923 Citroën 5CV, similar to the first car to drive round Australia in 1925. Jim Redieck celebrated the 50th anniversary in 1975 by driving this one round Australia. It averaged over 30 miles per hour and 40 miles per gallon and broke exactly one headlamp bulb. Inspired by Henry Ford's ideas, André Citroën built his first cars in Paris in 1919. Simple and practical, like the Model T, the early Citroëns had plenty of ground clearance and suspension with substantial axle and wheel movements. They were the first cars in Europe to be sold with electric starters as standard. They opened up new markets, particularly with women. Citroën became Europe's largest car maker. But Citroën espoused American mass-production steel body techniques. The European market, like the Third World market today, was not then ready to absorb the numbers of cars necessary to make such production methods viable. Citroën used every trick in the book to expand sales to match the capital cost of his huge American-supplied press shops. The aftermath of the financial crash of 1929 had bankrupted many car makers. Citroën was also in trouble. He decided to take one last gamble to save his company. In so doing, he changed the future of the motor car. When the traction avant was announced in 1934, it was a sensation. Few of the ideas taken on their own were completely original. The combination in a cheap, mass-produced vehicle was unique. Never actually driven a traction. Can I give it a try?
Be my guest.
It was, and still is, the modern motor car. Forward-facing doors. Front-wheel drive, independent front suspension, hydraulic brakes, wide track and low centre of gravity. That's just the start of the list. Plenty of cars of the 1980s still have to catch up. Driving the traction today feels just like driving a normal motor car, not a museum piece. The traction, already in production in 1934, was the complete antithesis of a vehicle then at an early design stage in Germany. The much-loved Volkswagen Beetle, with its rear engine, unstable swing axle rear suspension, and inconvenient layout, was a dead end. It had only two things going for it: reliability and air cooling. Since the mid-1930s, more than 300 million copies of the Citroën concept have been sold, as opposed to less than 100 million VW Beetle-inspired designs. Citroën died in 1935. The company had gone bankrupt. Michelin, the biggest creditor, picked up the pieces. And 20 years after the launch of the traction came the successor. The DS, or déesse, goddess, as the initials pun in French. Nothing remotely like it had ever been seen before. Streamlined even by modern standards, it had active hydraulic and gas self-leveling independent suspension with variable ground clearance and proportionately variable power braking. Just part of a package that left little scope for future car designers.
I think it's the sort of car that will be unequalled in long-distance events. I think we don't realise the benefit that the hydraulic suspension gives us in comfort. It's certainly much less tiring on the crew. It must be a lot less severe on the motor car. In extreme conditions, we know that it can travel very easily and quickly over very bad terrain.
Jim Rediex was a member of the crew of the DS Citroën that won outright the 1974 London Sahara Munich World Cup Rally by more than 28 hours.
The road was corrugated, it was rough, and it was continually rough, not just for 20 kilometres or something like this. It was rough for a long, long way.
The classic Citroëns, outstandingly capable compared with most other production cars, were still children of tarmac societies. 80% of the world's roads are unpaved and unsealed. Something more was and still is needed for the other 3/4 of the world. This is one of the 5 Citroën B2 vehicles fitted with the Kegres half tracks at the back, which made the first motorised crossing of the Sahara, 1922-1923. The rubber track system was developed by a man called Kegres, who was the mechanic to the Tsar of Russia before the revolution. And this really is the origin of the system to be found on, particularly on many military vehicles today, and vehicles like Snowcats. At the front, 2 huge additional radiators, which really make the point that with a water-cooled engine one runs into a lot of problems in desert temperatures. The temperature differential is not more than about 50 degrees between boiling and the temperature of the desert, which gives very poor heat exchange. With an air-cooled engine you'd have perhaps 150 degrees, giving you much better heat exchange. With no Model T Ford to fall back on, the world needed something cheaper, more agile, and universally useful. Between 1934 and 1936, the real joker in the Citroën pack was played. With a design brief of an umbrella over 4 wheels, capable of carrying 4 adults and a basket of eggs over a ploughed field without breaking a single egg, the family of 2CV Citroëns was born. It's still hard to believe that this extraordinary design has its origins over 50 years ago. Like the VW Beetle, its move to production was interrupted by the Second World War, and it wasn't launched till 1949. It is the uncompromised dynamic solutions of the 2CV that are so valuable as inspiration. The suspension is especially interesting. Simple leading and trailing links allow big vertical movements of the wheels without the dangerous changes of camber and scrub typical of other layouts. On a dirt road or mud, it's generally better if the wheels keep going in the direction that you want to travel. The problem with the 2CV arrangement is the ground clearance. The Africar needed a raised chassis and high-mounted springs. I talked to suspension engineer Tony Best. Get onto like a corrugated road. I mean, you know, that's what we're after, is the ability to be able to run for hours on end on corrugated roads.
The standard damper on Myra Pave, of course, has to go through a cooling splash every lap to dissipate the heat.
Every lap?
Yeah.
And how long's a lap?
between 3 and 4 miles.
So every 3 and 4 miles?
Yes. They cool the
You've
damper.
actually got to cool the standard damper. And if you didn't do that, what's going to happen
You'd
to
wreck the
standard
damper.
damper?
It just gets so hot that it fails and gives up the ghost.
And this is continuous run?
Yes, yeah. They will in fact stabilize.
Evidently, suspension relying on standard shock absorbers would not be much use to any vehicle in Africa.
The difficulty here is to decide how arduous the condition that we're talking about.
It could be hours and hours on end of the kind of driving that no one ever comes across in this country. So I think the thing that isn't realised about third world situations is that you're into consistent running for miles on end of the kind of thing that we think is either fun, you know, on a sort of farm track, or say the all-wheel drive brigade that tries to get Land Rovers around a short circuit. What they don't realise is that when you get into a 5-mile hill that's climbing 4,000 feet on mud, you can't take a run at it.
Yeah.
It's a completely different world. You've actually got to have traction all the way up. This simple, lightweight, hydraulic and gas spring would provide everything I needed. With the most critical element, the suspension, established, the Africar virtually designed itself. A vehicle designed to run on unpaved roads must be able to straddle or ride in the ruts made by trucks. Most four-wheel drive vehicles are too narrow tracked to do this and can become unacceptably dangerous to drive. There must be space under the car to clear the 10 to 12 inch, 250 to 300 millimeter high hump left by the trucks. Conventional 4x4s have about 8 to 9 inches, which simply is not enough. For long African distances, and to provide maximum passenger and load capacity, a comfortable upright seating position is essential. Using conventional components, a large ground clearance would lead to a high engine position and poor forward vision. Visibility is everything on bad roads and off the road. So I knew from the beginning that Africar would have to have a specially developed flat engine with integral transmission to provide a low sloping bonnet. But such a high and wide vehicle would be too heavy and have a huge frontal area, leading to too much wind resistance and low economy. So the characteristic shape of the Africar identified itself, and it looked like we'd be bringing back the running board. With the help of graphic designer Dick Vine, a first model was built. A decision had already been made to use plywood and epoxy resin for the main chassis structure, a construction method used on racing boats that have to be as light and strong as possible, and which spend their life in corrosive salt water. The idea is that the airstream goes through between the roof of the car and this false roof to keep it cool. We've got both insulation and... Sealing the wood with epoxy meant that we could use softwood as a renewable resource, and little energy would be consumed in the building of the vehicle compared with a pressed steel car. For prototype work, simple hand tools could be used. For production, a computer-controlled profile cutter would undoubtedly be needed, but at a fraction of the cost of working steel with presses and press tools. A full-size mock-up was built to check the ergonomics of seating positions, door openings, and visibility. You can still get through these doors.
That could come down a bit, actually. Although
Yeah, I think, no, I'm sitting a bit low at the moment.
Yeah.
I'll tell you what I don't like is that
It's above your head.
is almost directly above my head. for my height.
That can come right down, and that
You
can
see,
come up.
I need to go up a hair, but I've only just got vision to the front of the bonnet.
That must be much
Yeah.
lower.
This is
Gotta
going to
be
be
down
lower,
there
and the
somewhere.
bonnet's got to be up, because you've got to have eye line to the front of the bonnet,
Right.
otherwise you'll be in trouble. And I think this toe plate down here is a
That's the
little,
right angle.
no, it's a little too shallow. I think it's, these are going to be
Do you think
so
we'll
strong. I mean, you realise
Cap
that if,
these with Ali.
no, I don't think we do at all, because
Do you think people are going to lash jerry cans on?
you think about an ordinary car, right? And if I went like that, I'd make a huge dent in the rear wing. Right? What have I done here?
That's a right take.
Very small heel mark in there. Well, this is the first chassis that we built, our first attempt at the full epoxy ply technique. We tidied it all up and got a tremendous amount of weight off it, possibly as much as 70% compared with the original mock-up. And the main thing that it taught us was, apart from giving us experience in using epoxy, was just how stiff this kind of structure can be. A strong steel roll cage was used to give passenger protection and to form the door openings.
Okay.
Back in again. A steel subframe to hold the engine, bonnet and front wings was connected via the roll cage and the main suspension subframe to the central ply chassis. Initially, with no funding to develop the special engine, I used a 1300cc Citroën unit that approximated the Africar specification. It was flat and air-cooled.
Looks as though it's going to end, doesn't it?
Have you got F-green there?
I've got F3, yeah.
Fit through the side window. The first drive in a completely new prototype vehicle is as nervous as it is exciting. For the Africar, life started as it was intended to go on, off tarmac. It was a good day. A controlled ride, pretty well regardless of surface, a comfortable upright driving position, and definitely good visibility. Maximum speed to start with was barely 70 miles per hour, suggesting that the aerodynamics were about as bad as I'd expected. But the promise was there, and it was certainly worth going on to the next stage. Bessie was the second prototype. The shape had been radically altered at the front to try and improve the airflow. But a trip to the wind tunnel proved otherwise. The divided and raked back windscreen, deliberately retained to give good visibility and to avoid damage from flying rocks and stones spreading right across the screen, was the main problem. It was splitting the airflow to the sides of the car, instead of letting it flow smoothly over the roof.
Well, these are your results, straight off the computer.
A CD factor of 0.62 was hardly good enough, even for an all-terrain vehicle. With the basics of adhesion, ride and steering working well, and with the ergonomics sorted out, it was essential that the drag factor was improved. The new prototype, intended to be the pattern for the Arctic Equator vehicles, went from first line on drawing board to testing for India's Himalayan rally in 3.5 months. We fell out of the rally after 1,000 kilometers with fuel pump and vaporization problems. But it was not all bad news. With only 65 horsepower, we'd made 5th fastest time on one competitive section and had consistently run 7th, ahead of a Range Rover, a Volvo, Subarus, Ford Escorts and others. The rally had provided us a unique opportunity to test the design intensively under pressure. All the lessons learned were applied to the 3 Arctic Equator cars. Speed, as such, had never been a primary requirement for the Africars. But aerodynamics and economy go hand in hand. As we left Paris to continue our journey south, the prototypes ran freely on the autoroute and cruised with the traffic. At Mulhouse, on the French-Swiss border, we visited the French National Motor Museum. Based on what was originally a private collection, the museum is not a purpose-built national car archive. It was packed with Bugattis, the original, as people would say today, yuppie car, all style and elegance with little practical function. Interesting but flawed engineering, often quite old-fashioned even in its day. In 1984, there was not a traction avant, a 2CV or a Citroën DS in sight, and few significant Renaults or Peugeots. A poignant shrine to the fate of the motor car, spawned as potentially useful transport, then perverted by carefully classified consumerism. This is one of the 6 Bugatti Royales, built for but never purchased by the crowned heads of Europe. Across the border in Switzerland, we're on the road to Zermatt. But at Tash, the road is closed to all motor cars. We park along with everybody else, beside Fords and Fiats, Ferraris and Porsches. We've stopped here to remind ourselves of priorities. There is a perfectly good road to Zermatt, but the internal combustion engine motor car was banned from the town years ago. Air pollution and traffic congestion were 2 of the reasons. Yet Zermatt is a sizable town, not just an alpine resort. In Zermatt, people do a lot of walking. Or there are radio-linked horse-drawn taxis using sledges in winter and wheels in summer. And there are a mass of diminutive electric taxis and utilities. Almost all towns in the world could, like Zermatt, operate on unique transport mixes, with vehicles relevant to local energy sources and local needs, and with no private motor cars. Motoring over the Alps instead of taking the train through a tunnel underneath is an opportunity to appreciate the positive side of the motor car. Each of us our own engine driver, able to travel at our own selfish whim, wherever we wish and whenever we want to. If we can afford to buy and run the car, and if there's a road, and if the planet can afford the raw materials and energy to build the cars and the roads, and the energy to run the cars, and the death toll on the roads, and the noise, and the air pollution. It sort of spoils it, doesn't it? Top of the Simplon Pass, the Alps, the last barrier in Europe before the Mediterranean, are beaten.
The piston's all covered here in ice. It's all frozen solid. These icicles are solid. Absolutely solid. The mud flap still moves, just about.
How is the pickup doing? It's fine, no problem at all. Had to slow down half the time.
One would expect the six-wheeler to have to run in a lower gear because you're pulling all the weight.
Yes.
We're well overloaded.
Yeah. What's nice is that from here it's downhill all the way to Africa.
A word of that.
It's now early March, and thankfully spring is already on its way in northern Italy. We stopped at the Lamborghini factory near Bologna. A visit here in the mid-1960s was one of the main influences on my approach to Africa. Lamborghini, contrary to conventional industrial practice, actually make most of their own precision parts, either directly by hand or on simple modern computer-controlled batch production machines. An ideal way of approaching genuine low-volume manufacture. Unlike many so-called specialist car manufacturers, Lamborghini make their own engines while buying in the body panels. The only part that doesn't seem so precise is the intricate welded steel tube chassis. The heat from every weld distorts the frame. But Italians are practical when it comes to car building. Lamborghini is every bit as much a full car manufacturer as Mitsubishi. The difference is 1,000 vehicles a year compared with 125,000 vehicles a year from this plant alone near Osaka. But the processes are similar and the economic balance universal. Capital cost of production equipment and labor content per car are equally critical to low and high volume producers. An alternative approach can be found to the south of Japan. In the Philippines, the jeepney is every bit as stylish as a Lamborghini, and locally is competitive with the landed price of a Japanese equivalent. The body panels are cut from galvanized steel sheet by eye and with no drawings. And then the compound curves are hand-beaten. The jeepneys use copied World War II Jeep chassis and more or less any running gear and engines that can be found, either locally recycled or imported second-hand Japanese cast-off.
You watch me, Charles, and you'll see.
The Africar epoxy resin and plywood technique must require less skill, less labour and less imported materials than the jeepney, less capital per vehicle than the Mitsubishi. And as a production structure, the composite chassis must be more precise than the Lamborghini space frame. No complex jig and no torture to establish a consistent and exact shape. To fulfill the need for local manufacture, the total costs for the Africar system must be the same or less than those in the Philippines or Japan, not those of Lamborghini. On south again, towards the city that more than 2,000 years ago put the word Roman into a long, straight, paved road. Our landfall in Africa will be at Tunis, built on the site of Carthage, once part of the Roman Empire. So we're leaving Rome on the Appian Way, the old Roman road to Carthage. Next stop is Pompeii, to discard our Arctic equipment and take on supplies for Africa.
Over there. Let's put this with the spares in front.
Yeah.
Which was one we brought out originally from England.
We've already got one.
Once across the Mediterranean, we'll be very much on our own, with huge distances between points of communication and the possibility of purchasing even fundamentals.
It might be nice to have one or two things to...
Spare parts for vehicles are scarce in Africa.
Yeah.
And at this stage, spare parts for Africars are only those that we carry with us.
No, but he needs one or two things to put down there with the money.
Boarding the ferry at Trapani in Sicily, we can feel that we are loaded close to the 2-ton limit on the six-wheeler and about a ton on the pickup and the wagon. When we take on extra fuel and water needed for the desert, we'll be overloaded. A good test for the cars, but not the best way to tackle soft sand. "10,000 trouble-free kilometers in 4 weeks is a good start. A project this complex has many beginnings and many watershed points, and inevitably many crises. The difficult part has not been the research, design and construction. It's been the question of money, funding. 2 early reports in the late 1970s led in 1981 to what I called the White Report.
I've read it with fascination. I couldn't put it down. I think it's a fantastic idea. It's the whole concept is so exciting of producing a vehicle that requires minimal tooling. And
within a few days of completing the report, John Charnley, a Southampton boat builder, asked to see it.
I agree with you that all the vehicles we've got on our roads at the moment are really quite unsuitable. Well, I think the other attraction, and if we're going to make this work, is that it's going to require a lot less capital doing it that way.
I notice
then
you're saying we already.
trying to... well, I assumed that you'd shown me this because you wanted me to get involved in it, and there's nothing I'd like more.
No, I was just listening to that.
Well, it's a sort of project. I mean, as you know, I sold my last company last year to Guinness, and I set this boat project up more or less as a hobby. But something like this is the sort of thing that will turn me on for the next 10 years, and there's going to be the sort of challenge I'm looking for. So.
But cars are not like boats. Cars are killers and are regulated as such. And the Africar, intended for the most rigorous conditions in the world, was no leisure product. The first prototype was up and running within John Charnley's new estimates. But there was, as I had estimated in the White Report, still much work to be done and much money to be spent. After 8 months, in which no source of finance other than ourselves had been identified, John asked to pull out. Carolyn Hicks and I were back operating on our own resources. But we needed a revised prototype, capable of becoming a road-going version. In the best tradition of the post-war origin of Porsche, we worked at home, in our basement and garage at Shepherd's Bush in London. But it looked like an early end to the Africar concept. Then came a summons to the West Country. I'd never been too happy about our bankers because of their stubbornly maintained South African involvement. But I also knew them to be one of the largest banks in the rest of Africa.
Marvellous.
Do you like it?
Yes.
Yeah?
Put me down for one.
A year ago it was just a piece of paper.
Just a designer's dream, yes.
And a few encouraging words from you, if I remember rightly. I mean, the thing that we've been sorting out is the basic ergonomics of the things like the driving position, the pedals and so on. Because if you don't sort those out very early on, you get into all kinds of trouble later on when you build a structure and you can't change it.
Yes.
Anyway, shall we go in?
Yes. Sort it out.
Because as you remember, I brought you a paper a year ago, which you seemed quite impressed with.
Yes. So was the Merchant Bank.
Yes, but I believe merchant banks are not very interested in this kind of project, or at this stage.
At the time, we just had a piece of paper. Now we've got a motor car with 4 wheels sitting on the road outside.
Right.
It makes a difference.
Yes, but you've still talked again with merchant banks, and
Yes, that's true.
right, and there's nothing. I mean, there is nothing doing.
Yeah.
So really, the only thing I can do is to go forward on my own.
That's right.
Well, we tested the vehicle yesterday. It worked very well.
Good.
And now what we have to do is to go forwards to produce the pre-production prototypes, I mean, vehicles which are very close to the vehicle, which would be on the road.
How many of those?
Well, the minimum, I think, is 3.
Well, I've looked at the figures, and I've seen the car, and I've heard your test report of it. So I think really it's down to us now to support it, to see it on its way.
Very good, because I'm able to carry on developing the vehicle I want to do it. I don't have someone breathing down my neck, apart from you. And I think I'll move much quicker. Also, driving through what until very recently has been a war zone. The sole security for the whole Africar project was Carolyn's home and her income from editing television news in trouble spots around the world. Through what until very recently has been a war zone. In May 1983, I set up a workshop near Leicester to build first a test vehicle for the new patterns and then the cars for Africa. We moved fast. Work started on the 16th of June. By October, the test vehicle had proved itself, and the Arctic Equator chassis were complete. In mid-November, with the 3 cars on their wheels, we made plans to leave for Sweden on the 17th of December and spend Christmas on the Arctic Circle. Our bank borrowing was now at its limit. But we had a firm negotiated agreement that we could continue to use all of our income until we had completed the cars and the trip. And something happened at the bank. Income was swallowed, checks were bounced, the plug was pulled. Work almost stopped, and our departure was delayed. We were forced to go public in the media, which probably saved Africar, but it was too early. The response was overwhelming. The concept had obviously touched a nerve, and yet we had no strength or means to follow through. The only possibility was to get the cars off to Africa and prove that they would work under the conditions they were designed for.
You've got rocks about this.
Our bank manager, who'd offered crucial support until the cars had proved themselves in Africa, told us that the problem was nothing to do with us, that we were caught up in an internal dispute and couldn't avoid the consequences.
That kind of thing. I mean, the vehicles will either prove themselves or they won't.
So the problem was, apparently, the banks, not ours. To give them time to sort themselves out, we took their advice and fell back on their credit card. So the Africar prototypes have become perhaps the first all-new prototype vehicles to be completed by the means of plastic money. On February the 14th, 1984, early in the morning, and with just time to catch the ferry to Sweden, we finally left the workshop. Our four-wheel drive systems were disconnected. We didn't have the funds to finish them. Our bank accounts were frozen, our credit cards overloaded, and we had barely enough cash to cover the minimal costs of the journey. The six-wheeler and the wagon had never been on the road before in a completed state. In the workshop, we left behind us the basis of the next generation Africar, the first production chassis, but with little prospect of completing it or even seeing it again. In Tunisia, the sun was shining and oranges were ripening on the trees. The wagon and the more valuable parts of our equipment had taken 4 days to get through Tunisian customs. The enforced holiday had been welcome and probably essential. Being in a developing country with the Africars put a different perspective on the role and responsibility of banks and on our own financial problems. Every one of these vehicles has, in a sense, been financed by hard currency loans from international banks and funds. Often, long after the vehicles have been relegated to the scrapyard, the loans are still outstanding, and the interest-bearing unpaid interest is greater than the original sum lent. That is the essence of the third world debt problem. The Western banks are effectively bankrupt and have been for years because the debts cannot be repaid. Western economies are balanced precariously on a pile of worthless paper. By introducing genuine local manufacture of the single largest manufactured import, vehicles, the idea is that Africar could set an example for change. That has been our motivation and driving force. At least it's worth a try. But first we must prove the Africars. This is the ordinary road, and ahead lies thousands of kilometers of desert. It rained in southern Tunisia. We were driving across salt flats. The road became a slippery sea of mud. It was impossible to distinguish the sky from the flooded desert.
Bloody awful. Thick slime everywhere. Just boddling along like a load of old ducks.
Now we're heading into no man's land, towards the Algerian frontier and the real Sahara Desert, where it doesn't rain very often.